Hello friends, hope you are having a fantastic day today. So in this video, we are going to do a very popular LeetCode problem that is going to be pretty nostalgic for a lot of people. So without any delay, let's get started. The title of this problem is called letter combination of a phone number, and now many of the iPhone users won't know it. But in the past, phone actually did used to look like this, where if you have to type any messages, you will need to do it according to the keys that are present over here with the corresponding numbers. And people were so good that they were able to do it without even looking at it. But anyways, now coming back to the question, this is a LeetCode medium problem and also an extremely well-liked problem on LeetCode. Also has been asked at tons of popular companies. So let's see that what does the problem statement ask us to do. Basically, we are given a string containing digits from 2 to 9, because notice that in this problem, we are only given the characters from A to Z present between the letters 2 to 9. Now, inclusive. Now we need to return all the possible letter combinations based on the given digit numbers, and that it can be represented. For our convenience, we can return them in any order. So let's try to understand this with a couple of examples. Suppose we are given as an input just character number 4. So how many characters does this character number 4 can represent? Well, only 3 characters. So if we have to return this, the answer is going to be G, H and I as the answer that we need to return. But let's assume that instead of that, we are given the input as like 4 and 6. Then what should be the answer? So we know that 4 can represent G, H and I, and 6 can represent M, N and O. So the answer is going to be the combination of both of this GHI and MNO. So the answer would look something like, where you can see that currently we have 9 entries and they are combination of all the characters from these two entities, and that's what we need to return. So this is the whole problem statement. So let's try to see that what is the approach we can take to solve this problem. Now, number one thing is that currently we are only given characters between 2 to 9 as an input and nothing else. So first thing we need to do is that we will have to create a mapping, so that based on any given input location, we can actually identify that if the character 2 is given, we know that it can only have the possibility of storing ABC. Same way, if character number 9 is given, then it only has the possibility to store 4 characters W, X, Y and Z. And same way, we can store this in any such fashion so that this lookup needs to happen in big O of one time. So we actually have two options to do that. Number one option is that we can actually create a hash map, and inside the hash map we can store all the entities, and based on the key we can mark as the digits, and their subsequent values we can mark all of the entries. So that is option number one. This will yield in big O of one time complexity whenever we have to do the lookup. Second option is, since we know for sure that we are only dealing with characters between 2 to 9, nothing more, we can also create an array, and inside the array, based on the index positions, we can store the values. So let's assume that because in the array we have values like 0, 1 and then 2 and all, or so on and so forth. So for 0 and 1 we can store as an empty strings, because anyways they are not going to be part of our inputs, and starting from position number 2 we can start storing values as A, B, C and stuff like that. Now this is only for our convenience purposes, so that we can quickly look up what element we are trying to find. Now this is the pre-work that needs to be done in the solution so that we can do it in the efficient manner. Now let's see that what is going to be the optimal approach to solve this problem. Suppose as an input we are given the characters 2 and 3 that we need to return. Now we know that 2 is represented by ABC and 3 has been represented by DEF. That we actually take this given input 2 and 3, then we break this input based on all the digits it currently has. So first we get the digit 2. For digit 2, whatever the characters that it can represent, we create 3 decision trees based on that. So currently it can represent A, B and C. So we create 3 separate decision tree. And now, since this is not the answer, because we need to return the combination or the potential combinations that can be there. So this is just a part of the answer that we have created so far. But now we will have to complete the combination portion. So in order to do that, the number one thing we will need to do is to keep track that how many number of characters are currently present, or how many number of digits are present and how many are pending. So now 3 is pending. So we will append 3 with each of these decision trees, and we know that 3 is currently represented by these 3 values. So once again, for each one of them, we are going to have 3 separate decisions tree being made. Notice that currently at this very first location 2, we only had one entry per character inside our representation. But the thing is, in the input we were given 2 3 23, which means we were dealing with 2 character letter. But in the problem, we are only at half of the step, where we only have just 2, which means after creating this possibility, we still have to wait to add the values to the answer until we find this path where now the index position matches the total number of inputs that we are given. The moment this condition matches, we will need to add it to our answer list. So because over here we only had one characters, but now we had 2 characters, and even in the input we were dealing with 2 characters, we are going to add DA or AD in the answer. Same way AE is going to be part of the answer. Same way AF is going to be part of the answer. And the good thing about this is, because this is same operation being done multiple times, so we can actually keep on doing this. The moment we find out that this is one of the potential pair that we have already added to our answer, we can actually backtrack to see if A still has any more values that it needs to add to the answer. And yes, AE still needs to be added. So we will add AE. Once again, we will backtrack to A, and once again this AF needs to be added. So we will do that. Once again, we would backtrack to 2. Now we have completed all the path with A. So we will repeat the same process with B. And this is the whole answer we need to return. Now I know what I just explained might have confused you a bit. So that's why when we do go into the coding section, I will explain the whole thing in much more clarity. But this is the whole approach. Basically, we are simply using recursion and backtracking to solve this problem, because repeatedly we are doing the same operation, and we know that for this we need to have an terminating case. So terminating case would be that the moment we identify that one path or one combination contains the same number of characters as the number of input that is given or the index values, then we need to add it to the answer, and once again do the backtrack, keep on repeating the same process until we have exhausted all the possibility, and whatever the answer we found, we need to return that. Okay, so what is going to be the time and space complexity in this case? The time complexity is only going to be the number of potential combinations that can be made, which means the number of characters that are given. So let's assume that this currently has 3 times 3, 6 characters. So whatever the value is, so we need to do square of the number of given input for every single digit. So in total, it is going to be the number of combinations that are currently present. That is going to be the time complexity. For the space complexity, because we will have to create another array that contains all the mapping from the characters 2 to 9, we will have to store that, but that is going to be limited in scope. So instead of calling this as big O of n, we can actually treat it as big O of 1, because the space complexity is not going to change. So now let's see the coding solution. Okay, so first of all, we are going to initialize our string array, where we are going to mark first couple of entries as blank, and then we are going to mark all the values. So this is going to allow us to iterate over all the digits to the letters. And then let's start our code actually for the problem statement for this method letter combination, where we need to return a list of strings as the answer. So first we are going to initialize a combination string that we are going to return as the answer, and this is going to be the blank array list so far. Now first we are going to check for an edge case, that if the given number of digits is equal to null or digit.length is equal to 0, then we simply need to return combinations. If that is not the case, we are going to call our backtrack method, and we are number one thing, we are passing this list that we have created. We are also passing the input digits that we have received. We are passing an empty string that is going to be considered as the current combination that we have so far, and we are passing in 0 as the current index values that we have processed so far. Okay, now let's see this backtrack method. How does it work? So number one thing we are checking is that if this given current index location, if that is equal to the digit length, which means we have an answer that we need to add to our current combination. So we are going to add all the answer that we have found in the current combination to our combinations array list that we have created. If that is not the case, we are first of all going to differentiate the letters for every single index position. So let's say in the input we are given value number 2, then we would have ABC as the letters passed on, and then we are going to run a for loop across every single letter. But now this time we are recursively going to call back the method backtrack. We are passing in the same combination, same digits, but for the current combination, we have added the current combination plus the current letter we are working on. On top of it, we have also updated the number of increase value, index value. So if in the previous iteration, if we would have passed in value number 2, in the next iteration, we would have passed in value number 3. And that's how we will be able to start storing all the combinations in the current combination string that we have created. And this is it. So let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code. And our code runs pretty efficiently compared to a lot of other solutions, which is awesome. By the way, you can always find this coding solution in the GitHub repository we have, and the link is in the description, so you can check it out from there. Thank you.